let's look at some past question under what redox reaction. So in this video, I'm going to solve these two questions. They're under what redox reaction. So I'll be explaining extensively. Now, instead of me explaining this question here, you will understand so many things when it comes to what redox reaction. But I've done a complete video on redox reaction, right? Redox reaction means what? Oxidation and reduction. So our key point of the focus is going to be what? How to identify oxidation, how to identify what reduction, how to identify oxidizing agent, how to identify what reducing what agents. Just so these two questions, they are basis of the type of question JAMB normally would ask. So if you can understand what I'm about to explain to you, then you master up to like 60 to 70% of what redox reaction. Just so you want to stick to the end of this video and take down every single thing. The link to the complete video will be at the comment section or be at the description below so I can check out that video. Right? So first of all, let's give a quick background of what redox reaction is. So what is redox reaction? The word redox means what? Oxidation. No, it means what? Reduction. And what? Oxidation. Idea. We have called reduction and what? Oxidation. And there are different ways to define oxidation and what? Reduction. Just like you can define them as well in terms of what? Oxygen transfer, in terms of hydrogen transfer, in terms of what? In terms of oxidation what number. Depending on the type of question to be given to you, that's where you know in terms of what? Hydrogen transfer, oxygen transfer, and what? Increase or change in oxidation number or oxidation what number. So now we're talking about redox reaction. Now oxidation, let me just give you a song here. Oxidation, this is the loss of what? Hydrogen. Again, so whenever a species lost or lose hydrogen, it is what? It is what? It is what? Oxidation. Right there. So whenever a species lose hydrogen, it is what? Or decrease in hydrogen, it is what? It is oxidation. That's what you need to understand here. So oxidation first is what? Is the what? Loss of hydrogen or decrease in hydrogen. Just number two, this is the increase in what? Oxygen. So another way you can define oxidation is increase in oxygen. So whenever you are given a redox reaction, therefore is it hydrogen transfer or oxygen transfer? So we're talking about oxygen here. Oxidation is what? Oxidation is what? Increase in oxygen. So the species that gain oxygen is what? Is oxidation. Just what? And the species that also lose hydrogen, it is what? Oxidation. Very important here. The last one, which I would explain to you, number 3, this is the increase in oxidation number. Increase in what? In oxidation what number. Increase in what? In oxidation what number. So whenever a species increase in oxidation number is what? Is oxidation. Is what? Oxidation. Now reduction is what? Is the inverse of all this one here. Reduction is what? Is the inverse of all this one here. Now remember, oxidation is what? Is loss of hydrogen. Reduction is what? This is the gain of what? Of hydrogen. Right here. So the gain of hydrogen, so the species that gain hydrogen in the redox reaction is what? Is reduction. Is what? Reduction. So the one that increases in hydrogen. Number 2, this is the loss of what? Of oxygen. Right there. This is what is loss of oxygen. So the species that loses oxygen in a chemical reaction or redox reaction is what? Is reduction. The one that loses what? Oxygen. Just the last number 3, this is the what? Loss of what? Oxidation number or decrease in oxidation number. So whenever a species that go redox reaction, if it's what? Decrease in oxidation number, it is what? It is what? It is what? Reduction. Do you understand? So this thing you need to understand here. Another thing you want to understand here is that oxidation is what is now what? Reducing agents. Reducing what? Agents. Right there. Oxidation is what? Is a reducing what? Agent. This is thing to take note of here. Oxidation is what? Is a reducing what? Agents. Why? Reduction is what? Is the oxidizing agents. Is okay. Please, you have to understand this here. You have to understand this here. Right? Oxidation is what? Is the reducing agent. Reduction is what? Is the oxidizing agent. So if a question say that which of the species or ion is what? Is an oxidizing agent, what they're asking here, which of these is the reduction? Because oxidizing agent means what? It is the reduction. Reducing agent means what? Is oxidation. Just the word agent. Again, the word agent, oxidation is what make reduction occur. Now let me explain for you here. Here we have A plus B, give you what? C plus D. Now let's say this one undergo what? Oxidation. And you undergo what? Reduction. Is okay. Now this guy undergo oxidation to produce this guy here. When you undergo reduction to produce on here, it's okay. Let's, for example, here. What made this guy to undergo oxidation is this guy. This is the agent that make oxidation to occur. So this guy is what? Is oxidizing agent. Oxidizing what? Agents. What is the work of an agent? An agent is what makes change to occur. So anything that makes change to occur is called agent. So what makes oxidation to occur is not by itself, is by this guy. Just so this guy is now what? An agent of this guy to undergo what? Oxidation. So it's an agent. So oxidation, reduction is what? Is oxidizing agents. While oxidation is what? Is reducing agents. Idea is what? Is the reducing what? Agents, right? Why? Without oxidation, reduction cannot occur. So this guy is an agent that make what? Reduction to occur. So is what? Is a reducing agent. So what you have to understand here is that oxidation is what? Is a reducing agent, while reduction is what? Is an oxidizing what? Agent. Do you understand? So with these two things here, we cannot answer this question. So let's answer this question here. Please copy all things down and let's answer that question. Now, by the end of every question here, I'm going to give you a similar question for you to answer and what drop your answer at the comment section. Do you understand? Now, let's look at this one here. Look at this question here. Copper undergo reaction with what? Nitric acid to form copper 2 nitrates, water, and what? NO2, right? So whenever a question is being given to you like this, the first thing you want to do here, is what? Is to split the reaction into two half equation. Because this reaction I see here contain oxidation and reduction. Just so how do you split it into two half equation? Because when you split it into two half equation, that is when you can easily detect the one that is oxidation and the one that is what? Reduction. So once you detect the one that is oxidation, what happen here? You can really what? Know the oxidizing and what? Reducing agent. Now look at something here. Look at this question. You see that in the equation above, copper is copper oxidizing agent? Is it reducing agent? What are they asking here? These two electrical acceptor, it does not mean a base. So the main here, the thing here is these two things here, right? So now, how do you divide the equation into two half equations? It's very easy. Because copper reacts to this compound here to form this, and this, right? If you look at copper here, right? When you move here, it now form this guy here, right? Copper reacts here to form this compound you are seeing here, right? So it means that I'm going to write it down. I'm going to say 3Cu, right? Give you what? 3Cu NO3 right there. Now let's ignore all this one here because we are not looking at what balancing of the redox reaction first, right? Now why do we pick this one here? Because copper here, do you understand? Copper here, right? That is it. Copper here and what? Copper at this point, easy, right? So you can see that copper cannot move, cannot produce on here. Copper cannot produce on here. That is copper undergo reaction with this guy here to produce this compound. That is why we have it here, right? Now this is what? One half equation, but we don't know yet if it's the oxidation or what? Reduction. So, but this is not the first one here. Let's get the second one, right? Let's get the second one. Second one is what? HNO3. Our key point of focus here is going to be what? Nitrogen, right? Nitrogen is here. Now, although nitrogen is here, but nitrogen is going to move to this other point here. Do you understand? So HNO3 here will react with each other to form this one here. Already this one have react with each other to form this guy here. So this one also react with this guy to form this guy. Do you understand? So if you check it very well, here we have NO, here we have what? NO. So it makes sense, right? So here we have what? HNO3 giving you what? NO. Can you see that? So this guy moves to this guy here, and this one for this guy, and this one for this one here, right? So how do we know my oxidation and what reduction, right? So I'm going to define in terms of what? Of oxygen. What am I going to define in terms of oxygen here? Because I have oxygen here, and I also have oxygen here. So whenever a question is being given to you, now you are the one that will select how you are going to what to analyze it or to define it. If you are going to define in terms of what? Oxygen, hydrogen, or what? Oxidation what number. To me, the most convenient way for me to define this thing here and for me to get my oxidation and reduction is through oxygen. Why is it through oxygen here? Because yeah, there's oxygen here, there's oxygen here. If you check very well, copper here does not have any oxygen. You don't have any oxygen here, right? Copper, the oxygen here is 0, right? Now, but here, how many oxygen do you have here? Yeah, here we have 3 and 2. 3 times 2 is 6. That is, when copper undergo reduction reaction, it gain or it increases in what? 6 oxygen. 6 what? Oxygen here. Remember, so there's an increase in oxygen here. So there, increase in what? In oxygen. Increase in what? In oxygen. Can you see that? Increase in what? In oxygen, right? So remember, when especially or when an atom or molecule increases in oxygen, in our definition, is it oxidation or reduction? Now remember, it's going to be what? Oxidation. Why? Because oxidation is what? Is increase in what? In oxygen, right? Now, because there's an increase in oxygen from left to right, from the product to the reactor, for the reactor to the product here, there's an increase in oxygen. Therefore, this guy is what? Is oxidation. Is what? Oxidation. This guy is what? Is oxidation, right? Let's look at this guy here. Now, here we have how many oxygen? 3 oxygen, right? How many oxygen do you have here? 1. So is there increase in oxygen or decrease in oxygen? Right? It's very simple. If you move from 3 to 1, there's loss in oxygen, right? So unless oxygen, is it oxidation or reduction? You got it. It's what? Reduction, right? Because reduction involve decrease in what? In oxygen, right? So here we have decrease in what? In oxygen. Again, so that is here is what? Is what? Here is reduction. Again, now what can you conclude here? What can you say here? What is final thoughts here? That's that copper undergo what? Oxidation, while nitric acid undergo what? Reduction. Do you understand? That is it. Copper undergo what? Oxidation, while this copper undergo what? Reduction, right? Now, remember I told you that oxidation also is seen as the what? Reducing agent, right? So here you can see that Cu is oxidation, right there, and HNO3 is what? Reduction. Is what? Reduction, right? Now, remember, they didn't should identify the one that is what? Oxidation or reduction. They say should identify oxidizing agent and reducing agent. Just and they say should identify the one that is what? Oxidizing agent and what? Reducing agent. I told you that oxidation is also the same thing as reducing agents. So that is C is oxidation. Therefore, that is, let's say that is Cu is what? Is what? Reducing what? Agents. Again, C is what? Is reducing what? Agent. That is it. So C is oxidation. That is what? Is a reducing what? Agents. This guy here, you have seen here, nitric acid here, is what? Reduction. Therefore, we're going to be the oxidizing agent. So that is HNO3 is what? Oxidizing what? Oxidizing what agents. I get oxidizing agents, right? So there are things you need to pay close attention here. Now I see that in the equation above, copper is. Now I see that an oxidizing agent is that an oxidizing agent? The answer is no, it's not an oxidizing what agent, because copper is what? Oxidation. So therefore is a reducing what agent. So the answer is what? A reducing what agent. That is the answer. The one that is what? That is oxidizing agent is what? Is nitric acid, HNO3, right? That is the answer here. Just so I want to place one question on the board. By the time I finish off this one here, right? I want to place 2 questions on the board like this. So that you can answer those questions and leave the answer at the comment section. Just so let's look at this second question here. The second question is all about balancing of what? Redox reaction. Balancing of what? Redox reaction. But here they have done the main work for us. They only want us to balance what? The charges. They only want us to balance what? The charges. So how do we balance? Look at this question here. Is that look at this equation here. Is a what? Redox equation, right? It's a redox equation. Now say the value of y in the equation in the above half equation is what? So what is the value of y? Okay, this stuff here, right? They want us to get the value of y. Is my value of y 5, 4, 3, 1, right? If you check it very well, every other thing is balanced. Manganese here is 1. Manganese here is 1, so it's balanced, right? Oxygen is 4. Oxygen is 4 because here we have 2, here we have 2, 4, right? Hydrogen here is 4. Hydrogen is 4, right? What is not balanced is the charges, right? See, this E you are seeing here, it is used in balancing electron. It is used in balancing what? Electron, right? So let's remove this guy first. Okay, there's a reason why I'm removing this guy. There's a reason why I'm removing this guy. So when you are balancing redox reaction, please, I'm going to leave a complete video on balancing of what? Redox reaction. As a chemistry student, you need to learn how to balance redox reaction. So that by the time you see this kind of question, it should not give you what headache to answer, right? So they have done the whole work for you, because you have step 1, step 2, step 3, step 4, step 5 to step 7 when it comes to what? Balancing of what? Redox what? Reaction. This one here is the last step in what? Balancing what? Redox reaction. Is last step. So how do we balance redox reaction? Look at something here. Now, E, when we talk about E means they are balancing charges. E is used in balancing charges in a redox what? Reaction. So what are charges? Charges are what? Are the negative and positive sign, right? It is what is the electron that is transfer. If you check very well, here we have -1. Here we have the what? The reactant side. The reactant side, and here we have the products. Idea. Now, therefore, let's get our charges on both sides. Let's get our charges on both sides. Remember, charge can either be positive or what? Negative, right? So let's get our charge on both sides, on the reactant and the product, right? Here we have -1. Here, remember, the coefficient here is 1. So 1 times -1 is what? -1. So here we have -1. Now here we have H plus positive here, but here the coefficient is what? 4. 4 times 1 plus 1, you're going to be plus 4. It's okay. How do you get the -1? It's from this place here. How do you get the what? The 4. Remember, here is 1 plus 4. That's how we got plus 4. Do you understand? So -1 plus 4 is what? Is plus 3. Idea. It means that at the reactant side, I have plus 3 charges. Idea. Plus 3 charges at the reactant side. Do you understand? So how do I get plus 3? -1 plus 4. -1 plus 4 is what? Is plus 3 charges, right? Plus 3. Now let's move to the other side. If we move to the other side, there's those charges. This guy is a neutral atom, neutral molecule. This guy is a neutral molecule. So the charges here are what? Are 0. Because the charges are not balanced. The elements are balanced because manganese, oxygen, 4, hydrogen. But the charges are not balanced. And the matter of fact, here is plus 3, here is what? 0. Just so for you to be able to balance charges, you use what? E. And what does this E stand for? That's what you need to know here. What does E stand for? E stands for what? Subtracting charges or subtract electron. That is reducing electron. Any points you place this guy here, it means that you have subtracted electron. That is why at times you see it you subtract about E what minus I there. But there's no point of putting this minus here because E means what? Subtracting what? Electrons, subtracting charges, decreasing it. Just so if for example here you have 5 and you have 3 and I want to balance it, right? Then it is the side that have the highest charges I'm going to reduce. Just I will always reduce the side that have high charges. Hope you understand this. Understand this concept very well. So when it comes to what? To balance the electron, the side that have more charges or positive charges will be reduced so that they can be level. So if I have 5 and you have 2, how do I balance it here? Because this E needs to remove the unsubtracted electron. So I will subtract from here to get 2. So I'm going to remove 2 from 5 for me to get 3. Just so if there's a reactant, here is what product, or here is the product, here's the reactant, here is the product. I will subtract 2 from here, right? If you check it very well, here we have +3 and here we have 0. It is not balanced. It is not what balance. And E means subtracting electron. You want to decrease electron. So how will I do it for me to go to balance it? Since here is 0, here is 3, it means that for me to make here to be 0, because this guy is far higher than this guy. For me to make here to be 0, I will subtract 3 from here, because 3 minus 3 is what? Is 0. Just so what it means that because here I have +3 after calculating it here, I'm not going to say +3 what? E +3E. Just what does it mean? It means that +3 minus 3 equals what? 0, because this E means what? Subtracting charges, subtracting electron. That is meaning. So that I want to subtract 3 from this side for me to be able to get 0, so it will balance. From here now, both the atoms and the charges I want are balanced. Hope you understand. So this atom want to balance what? The charges. Just so the option here is what? Is 3. The option here is what? Is 3. So you have to master the art of balancing redox reaction. Just you have to master the art of balancing redox reaction. Now this video, the complete video, will be for my private students. So if you want to join my private class, send me a message that I want to join my private online class. If you have issues with your JAMB preparation, you have issues with math, chemistry, and physics, you don't understand that I'm here for you. I'm here to help you to conquer math, chemistry, and physics. Just if you enjoy this class here, please leave a comment section that you enjoy this class. And if you want to join my private online class, send me a message and be added to your private online class. But meanwhile, I'm going to list some questions on the board so that you solve those ones, because it's not good that after learning this here, you have to crack your brain to be able to solve similar problem. Once you are able to solve similar problem and get the answer, I think that you have actually understood the concept very well. Just so I'm going to place question on the board now so I can solve and do the answer at the comment section. Hope you understand. This is the one you are going to try here. We have question 1 and question 2. And there are some students have bad habits. 95% of students watching this video, they will not do this video, they will not try. And this is the reason why they keep on failing chemistry. Now you are watching video to this point here, and I've given you one for you to try. Guess what? Because you have so much in haste to go and watch, go and do nonsense, you not do it. Just I'm certain that the majority of you watching this video will not solve this thing. Try solve this here. If you cannot get it here, or you don't have to solve it here, leave like message that I should do the correction here. But try it. Now, what is the value of X here? And which of this is what is oxidation? Is the oxidizing what agent? You know that you don't understand. Please go back again, rewatch the video again. Just if you want to join my private online class, send me a DM or WhatsApp, and you'll be added to the group chat when you want to make a payment to join the class.